Hello, everyone, and welcome to a new series here at IoT for All, the #1 publication and resource for the Internet of Things. This series is called IoT Showcase. It is a series that we are focused on showcasing things happening in the IoT industry as it relates to new technologies, solutions, things that really kind of show IoT being used in the real world. And this first episode, I have the pleasure of having Blaine Mathieu, the CEO of Pratexo, on to talk about a power grid system, monitoring management system that they were able to create and deploy. So he takes us through all the steps that went in from ideation all the way to launching this thing. He shows us some images and examples of the early pilot stage implementation, and talks us through not just how it all works, but kind of what it went into building it. And then also the kind of benefits and the ROI that a solution like this would provide, helping anyone out there who maybe is looking for a solution similar to this, or has something that could has to know someone that could benefit from this, to kind of see how IoT technology really can come into play in this industry and to solve these problems specifically. For those of you who may be unfamiliar with Pratexo, they are a company that has built a plug-and-play edge computing platform as a service that greatly simplifies and accelerates the design, testing, single-click deployment, and ongoing management of edge nodes and microclouds required to host next-generation applications from the far edge all the way to the cloud. But yeah, so I'm very excited for you all to kind of get into this new series that we are launching today. If you haven't already done so, please like this video and subscribe to our channel on YouTube. But other than that, please enjoy this episode of our new series, IoT Showcase with Blaine Mathieu. Welcome, Blaine. Thanks for taking time to chat with us today.
Thanks a lot, Ryan. Great to be here.
Yeah, I feel like you were one of the first guests we had when we got into video on the podcast side, and now you're one of the first guests for this new Solution Showcase series. So I'm really excited to have you.
Well, thank you so much.
Absolutely. Yeah. Why don't you go ahead and reintroduce yourself to our audience? Tell us a little bit more about you and your company.
Absolutely. My name is Blaine Mathieu. I'm the CEO of Pratexo. We're an edge computing as a service company focused on industrial type applications like we're going to be talking about today. And let's see, my background very briefly, started as a Gartner analyst back in the dark ages, been involved in enterprise software and large industrial implementations for most of the last 20 years, and in the last 5 or 6 years, specifically in IoT, AI, machine learning, and now edge computing in these kind of systems.
Fantastic. So today, our focus is to pick out one real life solution, showcase it, talk about kind of how it's put together, what problem does it solve, who's the target audience, and then go through like an actual customer kind of experience journey for a second. So what I wanted to ask you to do is if you could just set the stage for our audience real quick, talk about at a high level what the solution is that we're going to talk about here, what problem does it solve, and that kind of thing, just to kick us off.
Yeah, appreciate you asking. And I get the point, because many solution providers in this space, their solutions can be applied to many different scenarios. And we've realized that too is a bit of a challenge. So
Sure.
we've recently brought to market something we call the Pratexo Grid Optimization Platform, which is based on the Pratexo platform, but is really specific to solving some critical issues that are facing the energy industry, especially the power distribution grids, and the distribution part of the energy industry in this particular case, not so much the generation part. We have different solutions for that. I'm going to dive into some of the sort of value or components of that.
Yes, please.
Yeah, sure. So first of all, why would a grid operator want to use this optimization platform? Well, they're always trying to reduce outage times to keep their systems up as much as possible, especially as plug-in EVs. It's just the system is becoming more and more critical just for every element of a modern society now, including transportation. They want to have the most efficient grid they can with high quality power and power balancing between the producers and consumers to avoid spikes. They're often the grid go down. MRO costs, right? What does it cost to keep your system up, keep it running, keep it maintained, at the highest possible efficiency at the lowest possible cost? Those are all the things we're working to achieve with the platform. Now, the reason I call it a platform and not a product is it's not a solution that does just one thing, very well focused on transformative maintenance on transformers on a grid or on power balancing, at the personal meters. It's actually a platform that lets you build multiple applications over time and add them in and stream them in as your grid starts to become more and more intelligent over time. So that's why we call it a platform, although it definitely is a solution for a
Yes.
set of very specific use cases.
Absolutely. And, when we're talking about solutions in general, there's always lots of questions around the different technologies that go into this, the different components, the hardware side, the connectivity side, the software side, you name it. And oftentimes, a big challenge is matching the correct technology components with what the customer is looking for to solve the particular problem in the particular use case.
Yeah.
In this situation, is that how big of a challenge is that? Or is it more of a general thing where this is a solution that probably can carry with it the same type of hardware, the same type of connectivity because the environments are so similar when it comes to this kind of the solution?
Well, these are complex environments, right?
Okay,
And I'm not sure which end of that spectrum it falls in. Probably a little bit of both, but there's always a lot of legacy hardware. Most of these grids aren't being built from scratch right now, right? They're in many cases decades old, and so there's lots
sure.
of legacy machines, devices. Some of them are putting off IoT data streams. Many aren't. Still a lot of analog equipment, even in many cases.
Okay.
And so you've got that to wrestle with. Then you've got, what kind of communication systems are you going to use to get the data around? And what we're starting to see is more actually private 5G implementations are just coming online now.
Mm,
But again, well, that's a little in the future. We're talking about today. Then you've got how are you going to process the data locally, what we would call on the edge. And you need a hardware layer to do that, a software layer, what I'd call middleware. It's a bit
mm,
of a swear word in my book, but I distinguish that from the actual applications and the machine learning models that are running on top of that actually take the actions in real time, that control or optimize the system, that do the analytics. So you need to make all of that work together. And
mm,
it can sound pretty daunting, but that's in fact exactly why we're bringing a solution to the market that
sure.
takes care of many of those elements instead of just one piece.
And would you say that kind of the integration and the different setups from a legacy system standpoint is one of the biggest challenges when it comes to this solution from an implementation standpoint? And in that same kind of breath, what should adopters who are listening to this or people who are considering adopting a solution like this, what should they be thinking about or considering prior to starting down this path of adopting a solution like this?
Yeah, yeah. Well, I think they should be thinking, what are the quick wins? If we could improve one thing right now that would reduce our maintenance costs, increase the efficiency of our system, increase our uptime, let's think about doing that, achieving that goal, right? And it's probably eminently achievable with the technology you currently have and maybe a little bit more. But then right away think about how do I get out of being stuck in with a siloed system, right? Because it's very easy, and we've seen this in the past with our customers and partners as well. They've got systems that are running their electrical grid or other industrial systems where they've got literally 15 different control stations, 20 different dashboards they have to
Sure.
look at. They're all totally siloed, right?
Right.
And again, I think you need to start small with individual use cases, but think about how this is eventually going to all and must be
Mm,
architected from the beginning, not just eventually fit
gotcha.
into one thing, but architected, right, to
Right.
fit into a unified whole. That's the challenge.
Okay. And roughly, and again, this probably varies from customer to customer, but is there a rough estimate on the implementation timeline for a solution like this?
Well, I think historically they've been measured in quarters or years,
Okay.
right? We've talked a little bit about this in the past. This is actually why Pratexo exists: is to dramatically speed up the time it takes to stand up one of these systems.
Okay.
I will say that the system that we're sort of discussing right now, and we'll go into a bit more detail. The last time we implemented this with a company, it took us 10 days to get the
Wow.
system up and running.
Wow.
And so, it is a little bit mind blowing sometimes for companies because, in fact, when we began talking to them, they were talking about getting it done by the end of 2022. That
Mm,
was their initial goal when we began these discussions.
wow.
And we said, well, how about 2 weeks? And they said, no, that's impossible. And so we went ahead and did it anyway, actually, and we showed it to him just a few days ago, and it was pretty amazing, actually.
That's
So that now, having said that, there's obviously that's an initial rollout of the system. If you're
sure.
talking about an electrical grid with 2,000 remote transformer stations, and you've got to put different hardware sensors in these devices, it takes time to just do the physical rollout of
Hmm.
some of these
Totally.
implementations, right? But to get the
Absolutely.
thing actually running on day one can happen very quickly.
Yeah, I think that's one of the biggest barriers to adoption in IoT that we've seen over the years is just how quickly can you get something up that proves the value to
Yeah,
either get stakeholder buy-in, to unlock more budget, to just basically show that this at scale, the value it has. So
yeah,
anything you can do to kind of expedite that time to market is fantastic. So
yeah.
speaking of the actual implementation, I wanted to ask if you could talk a little bit more about more specifics. So, talking about the system that you put in place, if you can name any customers, that'd be cool too. Just to bring this all full circle and show that this is not just a concept, this is actually being deployed and kind of what that looks like.
Absolutely happy to do it. In fact, oh yeah, you pulled it up perfect. So one of the companies I like to talk about is Kraftnet. We call them HKN for short. Norwegian power grid operator, thousands of power transformers located remotely spread across Norway. Many of these are small rooms, like you see in the picture here, that have a transformer inside. And what has to happen now in many cases? Well, first of all, these things are starting to put off lots of data. Most of it historically has been dark. Norwegian law prevents this data from being pushed to central systems over the public internet. They want to keep their grids secure from hackers. So pushing it all into a central cloud is not possible. Most of the data needs to be processed locally. So by doing edge computing in this grid, you're taking it from being dark data to live data. But the more interesting than that, I think, is now beginning to layer on intelligent applications at the edge. So each of these transformer stations now has a microphone attached to this edge node, which is listening to the sound the transformer is making. When transformers start to break, they make a crackling noise called partial discharge, and that means
Mm,
they're becoming less and less efficient, and eventually might even stop to function, altogether. And so the way they've done this in the past is Lars there on the left would trudge through the snow to the transformer station every few weeks and literally listen to it. Now we've got a machine learning enabled microphone, which is continuously listening for that sound and also gathering data to train the machine learning models to make these applications more intelligent over time. So this is one of these multiple use cases that we're layering into to HKN. If you
mm.
like, I can show you how we actually built this thing out.
Yeah, let's quickly run through that. That'd be cool.
Okay, I know we only had a couple minutes, but before we went to the transformer and energy grid edge, we built a smart grid simulator in our lab. And what we've got here, you can see there's power meters, transformers, there's edge gateways, there's temperature, moisture detectors. You can imagine very important in a transformer
Hmm.
station. You've got edge nodes, two microphones to listen to the sound, and cameras, because a lot of these stations are now being outfitted with cameras to detect people in dangerous situations.
Okay.
Another example of data you wouldn't want to throw all up to a cloud. You want to process that data locally.
Right.
So we started by building out the smart grid simulator in the lab, and then at the same time, we built the software architecture to run that middleware layer that I was talking about to actually be a digital twin of that hardware architecture. So what you're
Wow.
actually seeing is the same kind of devices,
Yep.
sensors, and the whole software stack that then lets you layer on top the application to listen to the sound of the microphone, the application to detect voltage levels, and if they're arcing below what they should be. So this is the software, you might say the digital fundamentally of what we built in the
Yep.
real world before they started to get put out into the transformer grid.
That's fantastic. Yeah, I appreciate you kind of diving into that a little bit more detail. It's really cool to kind of talk through, look at,
You bet.
and explore. As we wrap up here, I wanted to ask through these conversations, and maybe just for those out there listening, that this is applicable to, whether they work in this space or know people who work in this space. Where does the future of this kind of evolve into? Has that been something you've discussed with customers that seems to be potentially generally accepted in those conversations you've had, as like, this is where we're starting, which is what we've seen so far, and this is
Yeah.
where it potentially could go?
Yeah, it's I think about intelligence, right? The
Okay.
the future is about more autonomous, more intelligent systems being able to prevent things, not just predict issues, but prevent them from happening in the first place.
Sure.
Especially in the context of the electrical grid, a lot of this is about balancing producers and consumers, local battery storage. You now are talking about Ford trucks powering your house at night, right? There's so much complexity in this system, and these new technologies, I think, fundamentally are about using intelligence to
Sure.
reduce that complexity.
Absolutely. And for our audience out there who wants to kind of get a deeper dive into this solution specifically, what's the best way to do that? Is there somewhere on the site they can go? How can they discover more?
Yeah, easily just go to Pratexo.com. You can find more information specifically there about this use case and
Perfect.
this company and many others, and reach out to me on LinkedIn as well.
Fantastic. Well, Blaine, thanks so much for your time. You hit everything I was hoping to cover. I think our audience get a lot of value out of these more very specific solution focused kind of showcase videos to show what IoT can really do applied in different industries to solve particular problems. So, thanks for taking the time, and love to have you back to talk further about some other solutions.
Thank you, Ryan. Appreciate it.
All right, bye. All right, everyone. I hope you enjoyed that episode of the IoT Solution video series from us at IoT for All. If you did, we'd really appreciate it if you would like this video and subscribe to the channel if you have not already done so. If you have a potential solution or something in the space that you would love to showcase to our audience, please email me directly at ryan@iotforall.com. I'd be happy to discuss what it is that you have going on and find ways to get that out to our audience. But other than that, I hope you enjoyed this episode, and we'll see you next time.